Please note that the video has been created on the program with English interface, but the program is available in more than 25 market versions. The current list of available market versions of InstalSystem 5.5 you will find at www.instalsoft.com. When opening a new project, the program always offers default project settings thanks to the availability of at least one project template, which you can review and modify. In the following part, you will see typical project general data settings modification. The window on the right displays a list of catalogues loaded into the project. The window on the left displays a list of other available catalogues. The program is equipped with neutral product catalogues and catalogues of selected manufacturers. Filters allow you to quickly and easily find catalogues of selected product groups and load them into the project. The Storeys Management tab allows you to create the required number of floors and specify their data. Entering the correct dimensions, such as story height and slab thickness, will allow for correct and accurate consideration of the vertical duct sections, which the program automatically generates. If ventilation system is planned in a false ceiling, option under upper slab, it is crucial to correctly determine the thickness of the false ceiling. Ceiling air diffusers and extractors inserted later in the project will automatically align with the false ceiling. If ventilation system is planned in the floor, option on lower slab, the upper edge of the floor air diffusers and extractors is aligned with the floor surface. After selecting the distribution method, you can adjust the default distances of the ventilation elements from the upper or lower slab. Thanks to the ability to quickly change the default installation layout at any stage of the project, you can quickly and easily rearrange the installation layout. In our example project, we will add one story below with the basement and one above with the first floor. On the Types and Default Data tab, you can set default rigid and flexible duct types. Based on the system topology, the program automatically distinguishes the location of individual ducts. This allows you to quickly specify a different duct type and diameter, for example, for connecting the air intake and air exhaust to the heat recovery unit, and a different one for the air distribution to the air diffusers and extractors. You can also set default types for other system components, such as the heat recovery unit or air handling unit, ventilation manifolds, air diffusers and air extractors. The heat recovery efficiency of the heat recovery unit can be derived from its data stored in the library or entered manually. The latter option is useful when, for example, you want to include a ground heat exchanger in the overall heat recovery efficiency. The program also controls maximum velocity in ducts and terminal points and displays the warning after calculations if the value has been exceeded. program determines the amount of air to be supplied by the supply air diffusers or removed by the air extractors based on room data. Two methods are available, based on the minimum exchange rate and the volume of the room based on supply and exhaust air volume values. Additionally, the program can diagnose whether the minimum amount of fresh air per occupant required for hygiene reasons will be achieved based on the room data. To correctly determine the supply air temperature in the rooms, the outside temperature must be verified and, if necessary, corrected. Subsequent data fields allow you to specify the required minimum overpressure at the air diffuser and minimum negative pressure at the extractor, as well as set tolerances for the obtained results. This checkbox allows you to also consider non-preferred gears when determining fan speeds according to the data in the specific product specifications. Of particular note in this tab is the Bill of Materials control option. Automatically generated bills of materials can be generated for the entire project, divided into individual stories, or into individual building units, typically apartments. This latter option is especially useful for multi-unit residential building designs, allowing for the preparation of a customized bill of materials for each apartment. Okay, so we have checked all important settings in General Data window. Please remember that all these settings can be saved as a project template to avoid necessity of repeating these steps in next projects. To load the drawing with the underlay, change the screen arrangement. Switch to the Underlay editing scope and use the Import Underlay icon on the ribbon. You can use 2D drawings in DWG, DXF, PDF, PNG, and JPG formats as the underlays. Alternatively, you can use 3D architectural building models in IFC BIM format. This tutorial demonstrates the design process with 2D drawings. To learn how to load and process a 3D architectural building model, watch a separate tutorial on our YouTube channel. After loading, the drawing must be scaled. Optionally, you can also hide redundant part of the drawing with the icon Visible Underlay Area. If the building contains multiple stories, repeat these steps for each story. To correctly position subsequent stories above each other, use the reference point element, insert it at the same point on each story. Drawing axes of walls, chimney corners, and shafts are most commonly used for this purpose. All elements needed to create building structure are available on the ribbon after switching to Construction Editing Scope. In the minimal variant, only rooms should be indicated on a previously loaded underlays using the Room icon, and this variant will be presented in this tutorial. To insert rectangular rooms, simply double-click with the left mouse button on two opposite corners of the room and finally confirm with the right mouse button. Other shapes require clicks in all the corners. Alternatively to his approach, It is possible to prepare a complete building structure, including walls, roofs, ceilings, windows, and doors. This produces a much more attractive visual effect in the 3D model, more accurately representing the actual building structure, but requires more work. After inserting the rooms, their data should be verified and completed, particularly the required supply airflow rate, required exhaust airflow rate, or minimum air exchange rate. Data can be entered individually by selecting the room and the appropriate field. Data can also be automatically completed based on the selected room type. This option requires prior completion of room type data in the project's general data. Setting the correct internal room temperature value will allow you to accurately determine the exhaust air temperature, which transfers heat in the heat recovery unit to the supply air. To select few rooms for bulk editing their data, hold Ctrl and click on the round room labels. To easily identify rooms in calculation results, it's beneficial to assign them individual symbols. This can be done manually by selecting the round label for each room, or semi-automatically by modifying the pattern appropriately in the Name Patterns tab in the General Data window. And then using the Symbol Assignment function. After clicking on the tool icon to assign symbols to rooms, click on their round labels in the appropriate order. This feature significantly speeds up the completion of symbols in projects with multiple rooms. Okay, this way we have completed the third stage. Let's go to the next one. The program features a quick design mode using virtual ducts. This unique mode allows you to optimize your installation by verifying various design solutions before drawing any ducts. This significantly shortens the work required to obtain preliminary calculation results and a bill of materials. In the first step, enable the Create Virtual Connections when there are no graphical connections option in the general data. If the bill of materials should include estimated ventilation duct lengths, also select the List Virtual Elements option. In the fields below, you can use coefficients to influence the estimated duct lengths. For air diffusers and air extractors with more than one connection point, the program can determine the required number of ducts based on the criterion of not exceeding the maximum air velocity. In the second option, program assumes that ducts are connected to all available connections points and distribute the required airflow evenly. Due to the lack of graphical ducts in the drawing, you should also indicate which type of duct, rigid or flexible, should be used in each main location. After switching back to the 2D editor, insert the basic system components. The heat recovery unit or air handling unit, manifolds, air intake and air exhaust, and air diffusers and air extractors. Additional auto mode settings can be used to place the air diffuser or air extractor at a specified distance from the wall. After inserting the elements, you can run check connections. The program has been equipped with advanced logic for connecting elements with virtual ducts. If the correct connection cannot be interpreted automatically, clear diagnostic messages are displayed, allowing for quick data addition or correction. The basic system elements are already in the project, so we can now run the calculations. When they are finished, first check in the diagnostics window whether the flow velocity hasn't been exceeded in any of the elements and whether the total amounts of supply and exhaust air are balanced. If not, you can go to Results and browse detailed result tables. All elements in the results can be quickly identified in the project by using zoom icon. To balance the flows, go back to room data, correct the values, and run the calculations again. Virtual Ducts calculation mode lets you quickly check different variants. See how quickly you can check how duct's diameter reduction will affect the required fan pressure. Just see how simple it is. If the boxes with the ability to connect multiple ducts have been used, a quick glance at the drawing will let you know how many ducts should be connected to a given element. Connected points are indicated by a half-solid square. This information can be also displayed in air diffuser or air extractor label after label contents modification. To put the labels quickly on all air diffuser and air extractors, use Project Browser window to select these elements. Once you're satisfied with the results, you can finish the project at this stage by printing or exporting the drawings after they've been prepared. You can also attach detailed result tables to the drawings and, most importantly, a bill of materials. More information about contents of result tables and printouts or export preparation you will find later in this video. We will continue our project and move on to the next stage, drawing the ducts. First, we will connect manifolds with air diffusers and air extractors with flexible ducts. If you need to rotate the element, you can do it by hot point or by choosing proper function from the ribbon. With the support of auto and auto modes, drawing and connecting the ducts is super easy. Next, we will connect heat recovery unit in the basement with air intake and air exhaust on the ground floor. For that, we will use vertical ventilation duct. Once placed, its symbol, range and type must be defined. To connect heat recovery unit in the basement with manifolds on the ground and on the first floor, we will use vertical ventilation duct again, but this time with rigid ducts. After connecting the installation elements with ducts, we'll use check connections function again. This also sets the elements to the elevations based on the given story, which can be verified in the 3D view. Further adjustments to the vertical installation will be made after performing the calculations and analyzing the diagnostic messages. After completing the calculations, we'll first analyze the diagnostic messages. The fittings, elbows, and T's required for proper connection of the system components are determined automatically. This message informs us that due to insufficient space, the fitting at the duct connection could not be selected. To eliminate this warning, we'll use the 3D view. Verifying and eliminating the cause of this warning is easier thanks to the display of the fittings in the 3D view and the flexible control over the visibility of editing scopes. And visibility of stories. To adjust the elevation of the duct individually, after selecting it, select Manual Elevation of Sections in the Vertical Layout of Pipe Run field, or Manual Elevation of Nodes if the ends of the section are at different elevations. The elevation can be changed in the label of the selected section or in groups by selecting the labels while holding the Control key. After recalculating the project, automatically determined elbows and T's will appear at the duct connections. The remaining messages of this type can be eliminated in a similar manner. To eliminate collisions between ducts, you can use the option of inserting additional points on the ducts and adjusting their elevations accordingly. It's beneficial in this situation to display both the 2D and 3D views simultaneously. After refining the model and recalculating the project, let's now take a closer look at the calculation results. Much of the information can already be read in the plan views or in the 3D model by pointing the mouse cursor over an element. To make the model easier to analyze in 3D, we will display drawings with underlays. Detailed results can be analyzed in the result tables. Results tables contain detailed results grouped into several tabs. For example, in the Recuperator's Ventilation Units table, you can check the required fan parameters and the parameters for the fan gear determined by the program. The program also supports fans with variable speed control. In the Fresh Airflow Routes and Exhaust Airflow Routes tables, you can trace all fresh and exhaust air routes, for example, to diagnose which component is generating the highest pressure loss. The Room List Ventilation tab allows you to monitor the achieved airflows at the level of each room and building unit. The tables can be printed or exported to some of the available formats. To supplement the drawing documentation, we'll add labels for ducts and other installation elements. As with labels, the style of each element presented in 2D and 3D view can be modified. Finally, to print the drawing, go to the Printout tab and insert a page layout, verifying and, if necessary, modifying its parameters, primarily the paper format, orientation, and print scale. Additionally, we can also insert a drawing chart, which is available in several predefined templates. It's also possible to use a custom, prepared in XLS format. The chart is filled using its data table. After switching to the Printouts window, a preview of the newly configured print page will be available at the bottom of the list. Thanks to the ability to control the print content in detail via the Elements Layers field for the selected page layout, we can, for example, deliver plan views in two versions, with and without duct drawings. Finally, when all drawings are ready, they can be printed or exported to PDF or another graphic format. Alternatively, 2D drawings can be exported to DWG or DXF formats after configuring the export options in an additional window. The 3D installation model can be exported to DWG-DX F3D or IFC formats, but the visibility of these options depends on the availability of BIM modules in the package. If there are different ending elements available for chosen air diffuser or air extractor, the appropriate variant can be selected in its data table after selecting the element. If your manifold has multiple rows of connection points, you can easily change point of connection of particular duct. Simply select the duct and click the hot point. One of the data that can be included in the catalogue is the bending radius of the flexible duct. If the manufacturer provides this data, it is saved in the catalogue. If the data is missing or you want to change it, you can manually enter the bending radius after selecting the duct. The roof air intake and roof air exhaust are automatically created at the end of the vertical ventilation duct element. Simply select the element and select the appropriate variant in the element at the end of vertical duct field. If different roof intake and roof exhaust variants are available, you can select the appropriate one in the type field below. Additional components that can be added to the ventilation system project include an air heater, an air cooler, and an acoustic duct silencer. The program calculates the required heating output for the heater based on the required supply air temperature and the incoming air temperature. Pressure loss is calculated for both components based on the component's catalog data.